The law of cosines. In the previous video, I went over the law of sines, but now I'm going to go over the law of cosines. This little segment is actually split into two parts, two videos. This video, I'm going to introduce you to the concept and the formulas of the law of cosines, and in the next video, I'm going to be focusing on actually using the law of cosines to solve for some realistic problems and doing some example work using the law of cosines so you get an idea of how to use it and where it could be used. There is one important thing, though, that I forgot to mention in the previous video that's extremely critical to know. So in the beginning of this trigonometry crash course, I went over right triangle similarity, such as ASA, SSA, AAS triangles, and etc. So if you don't remember that, I highly recommend you go back and watch the right triangle similarity video to at least see the types of triangles that I kind of went over there. And I only briefly touched upon it. But there's many other types of triangles. So the law of sines and the law of cosines cannot be applied to just any triangle. They actually have specific types of triangles that they can only be applied to. And there's a very simple trick that you can use to remember which triangles go to which type of laws. So for the law of cosines, there's only two types of triangles that the law of cosines can apply to. And that's both SAS and SSS triangles. Any other type of triangle, whether it's like AAS, AS1, S2, or ASA triangles, etc. Alright? That's for the law of sines. So if you have either an SAS or an SSS triangle, and what that means, if you forgot, an SAS is when you have two sides known, you know two sides, and then you also know the angle that connects those two sides, it's between those two sides. And then obviously SSS is you know all three sides of the triangle, but none of the angles. So if you have an SAS or an SSS triangle, one of these two, or maybe you have two triangles and one's an SAS and one's an SSS, use the law of cosines to solve for sides or angles. But if you have anything else, like any other type of triangle, AAS, AS1, S2, ASA, if you have any of these types of triangles, you're going to be using the law of sines. And I could probably draw it a bit neater in here, just because my handwriting was a bit sloppy here. I want you guys to be able to see that. Let me change the color again. So remember that's even worse, AAS, AS1, S2, ASA, and etc. So if you have any of these triangles here, use the law of sines. But if you have an SAS or an SSS triangle, use the law of cosines. Now, there's there's 6 total equations or formulas for the law of cosines. And I like it's more common to divide it into two groups. I like to divide it into two groups, and it's just more realistic too. So the first group is when you're trying to solve for a side. So you're solving for a side. So you're solving for a side on the triangle. And you're going to use one of these 3 equations here. So the first equation is a squared is equal to b squared plus c squared minus 2bc times the cosine of angle A, right? The next equation is b squared is equal to a squared, so bad 2a squared plus c squared minus 2ac times the cosine of angle B. And then the remaining one of this group is c squared is equal to a squared plus b squared minus 2ab times the cosine of angle C here. So it's important to note that, and it probably isn't really anything you were confused about, but I just want to go over this briefly just in case. So this a squared, this b squared, this c squared, this is what you're solving for is the side. So this is the side you're solving for. Let's say you're solving for side A, well, you're going to follow this formula. You're solving for side B, follow this formula, side C, it's this formula. In some instances, it actually doesn't matter which one of these equations you use to solve for a side, but in some instances, it actually does. So a common pattern you might have noticed is that in the equation, for the side that you're solving for, you do not use that variable anywhere else in this equation here, on the other side of the equation. So you're solving for side A, but you don't see A anywhere here. You see the other two sides here, besides this A, and that's actually not the side A, that's angle A. And what angle A is if you remember from the Law of Sines video, angle A is opposite of the side A, right? And, side A is opposite of angle A. It's the opposite side of angle A. But you don't see A anywhere else. You don't see the side variable, the variable that represents a side length, specifically A, anywhere in here. Same with this one. You don't see B anywhere in here. You don't see the side length B in here. And with this one, you don't see the side length C in here. You see the cosine of angle C, or you see the cosine of angle B here. We don't see the side length variable, the variable that represents the side length here. Another way to remember, or another addition to remembering this, is that it's always going to be side length squared plus side length squared minus 2 times the two side lengths you just used. So it's going to be plus minus between these. It's going to be side length squared, 2 times side length and the other side length, and then times the cosine of the opposing angle. It's a lot to take in, and you can always find your own ways to remember this, and you don't necessarily have to remember this if you just write it down in a notebook and you have it on side with you, because not everybody, you're not always going to be expected. You almost never, it doesn't matter what mathematical field or kind of field you go in, you could be a physicist and you're not expected to remember every single equation. And even the most elite mathematicians, the most elite scientists, engineers, they actually don't remember all of this. And yes, it's cool if you do remember this, but you don't have to remember this. I just recommend that if you do, want to put yourself to the challenge of remembering it, those are some simple ways to remember that. So let's move on to the next group of equations here. And this is solving for an angle. So you're solving for an angle. So you're solving for an angle. You're solving for an angle, all right? So this is typically, there's 3 equations just like this, and they actually follow a very similar pattern. So to start, let's go over the first equation here, and I'm going to kind of start with C instead of ABC. So cosine of angle C. So you want to find this angle. So cosine of the angle you're trying to find is equal to side A squared plus B squared. So the other two sides that isn't C. And you're going to minus the opposing side of the angle you're finding for. So in this case, the opposing side of angle C would be side C. If it was angle A, it would be minus A squared. And let me get my line tool just to make this neat. And then you're going to divide it. You're going to divide it by 2AB. So you're going to divide it by the two sides that aren't involved with C, or whatever this letter is here. It's a bit more complicated. Well, I'm sure you can always find your own patterns and figure out your own ways of remembering this. And as the pattern continues, cosine of angle B is equal to A squared plus, I had to think about this one for a second, C squared minus B squared. And let me get my line tool again. A squared plus C squared minus B squared divided by 2AC. And then the cosine of angle A is equal to B squared plus C squared minus A squared. And let me get line tool again. And here we go. And then 2BC. So the BC, the AC, the AB, that comes from these two sides here, this A and this B, they kind of go down here. The A and the C go down here. The B and the C, they kind of come back down here. And that's how you can remember the formulas. And that is the introductory to the law of cosines.